That's right, the LCD screen is back. And we're going to use it today as an output for an Arduino powered digital voltmeter. Now, I'm using the Nano this time, but the Nano and the Uno are basically compatible. Well, I mean, they're not basically compatible, they are compatible. So it really doesn't matter. I'm not going to go over the whole hookup. Look at the video on intro to using an LCD screen. I will link it down below here. Hey, look at that, there's a subscribe button. But what we're going to do today is we are going to create a simple voltage divider circuit that will allow us to read voltages from 0 to 50 volts on the analog 0 pin of the Arduino. Now, the reason we need to use that voltage divider is because you don't want to be putting any more than 5 volts onto any pin of the Arduino, or bad things will happen and the magic smoke will escape. Nobody wants that. Just ask that one Nano that I hooked up wrong, and well, never mind. Okay, so we're basically out of room on this board, so I'm just going to add to it a little cute little tiny breadboard so we have some more room to work. Now, we need a 10-to-1 ratio for this voltage divider, and we want to make sure we use high enough values so that we can read the 50 volts. So for that, if my fingers can pick it up, we are going to start. Come on, focus. Focus. Try again here. There we go. With a 100 ohm resistor. All right. So the 100 ohm resistor is going here. Now remember I said 10-to-1. That means that our other resistor needs to be a 10K. Come on, focus. Wow, I really don't want to focus, does it? Okay, well, it's a 10K. Now, to create our voltage divider, remember we want to put those two there so that they're basically, well, not basically, so that they are lined up in the same hole. All right. So now from the 10K, we're going to our ground rail. And from the point where our voltage dividers meet, we go to A0. And then I'm going to use this nice little screw terminal here. Give us a place to input our voltages. And I'm just going to hook all our grounds together, because remember, we always need our grounds together. So now we put our positive voltage here, our ground here, and with a little bit of coding, we will get the output right there on the Arduino voltmeter. Now, due to the fact that my 100K and 10K resistors probably aren't exactly 110K and 10K, there's going to be a little bit of error. It's going to be small at lower voltages. It's going to be higher at higher voltages. That's why you pay so much for a nice fluke meter. They know the exact values of the resistors, and they compensate for everything. All right, let's go write some code for this. Okay, here's our code. And once again, I copied these over here so that you know how to plug this in. Again, if you plug in the anode and cathode wrong, boom, no more LCD. Alright, first step as always when using the LCD display, we need to include the liquid crystal library. Next, we're just going to declare some variables. A floating point variable called voltage, a floating point variable called temp, and that's for temporary, not temperature, and an integer called analog value. Then we will initialize the LCD display. Those match up to what we have up here. And we will have our setup. LCD begin 16:2, we're telling it the size of the LCD. Setting our cursor in the upper left. Printing out Arduino based. Then we're moving the cursor down one line and printing out digital voltmeter. Then we wait, because it's always nice to pause and take a breath. Next, we will read the value at pin A0. Okay? This is where we're using our temporary variable. Since we have the 10 digit ADC, wow, I'm kind of losing it today. We have a range of 0 to 1024, and then we have our 5 volts. So our analog value, which has been cooked down by the voltage divider, we're knocking it back up to something where it should be. So if we put in 50 volts and the voltage divider knocks it down to 10, we need to multiply it by 5 to get back to 50. Then we divide it by the 10-bit ADC. And then we come down here and we say voltage equals temp divided by 0.0909. Okay, now you're saying, why do we have all of this math going on? Well, unfortunately, science is based on math. But it goes like this. In order to read 50 volts, we have to have the values of our resistors R1 and R2. So R1 divided by R2 minus 1 must be greater than 10, or greater than 5. It comes out to 9. So we're dividing that by 10. And that's where it all comes together. Now we say if voltage is less than 0.1, voltage equals 0. Then we clear the LCD, we set the cursor back in the upper left hand corner, and we print voltage, a space, and then we LCD print the variable voltage, which is the result of all of this headache inducing maths. Then we skip over 13 columns. Why? 1, 1, 2, 3, 4, 5, 6, 7, 8. Then we say 9, 10, 11, 12, 13. It just gives us a nice spacing. And we print V, not for victory, but for volts. And then we wait for 30 milliseconds because after all that math, the Arduino is tired and just needs a pause. But that's it. Nothing much to it. Some variables. Our LCD and it gets initialized. We read the value at the pin. We do a little bit of math on it, and then we output it. And there you have a simple Arduino-based DVM. Alright, let's go take a look and see how bad the error actually is. Okay, here we are. As you can see, the Arduino is all powered up. We have our power supply hooked into our little voltmeter attachment. And you can see the voltmeter on here, which is not all that accurate, is reading 3 volts. We're reading 3.4 here. So if we adjust the voltage, go up to 5, you see we're getting 5.59. And like I said, this is definitely just an exercise in voltage dividers. You see at 9 volts, it's reading 9.9. So it is not incredibly accurate. And again, a lot of that has to do with the actual values of the resistor, the 10K and the 100K. Now, I tested them on my on my transistor/component tester, and the 100K read like 98.2 and the 10 read 10.2. So you can see how with the values there being a little bit off, we end up multiplying that error here. So let's try and take this as low as we can go. 1.2, and we're reading 1.13. So we're, 7 hundredths of a volt off. Now let's try and take it as high as we can go, which should be up around 12.2 volts. Okay, 12.1, and you can see the error is multiplied. We were at 13.3. But it'll never be a replacement for your fluke, right? But it is a good experiment and a good exercise in voltage dividers and a useful way to use your LCD screen. So if you like this sort of thing, give me a thumbs up, share it, and if you haven't subscribed yet, you're going to end up on Santa's naughty list, So subscribe already. There's a button right there. Click it. And I'll see you next time.